Alright, so today we're going to be putting together the Dinosaur kit. The Dinosaur kit is a little game based on the Arduino that plays the dinosaur game that you find in the Chrome browser. So the kit comes with several parts. We have an Arduino, we have an LCD character display, we have a resistor, a little capacitor. We have 6 little buttons here. We have an integrated circuit. It's going to be your multiplexer. A little socket for that to go into, some button caps. We have the circuit board for the controller, the circuit board for the I2C bus, and several wires, header pins, and other things. So to get started, the first thing we're going to do is we're going to put together the controller. The controller has really the majority of the parts, so we'll start with that. So to put the controller together, let's get this stuff out of the way. We're going to need some header pins, your resistor, capacitor, buttons, our integrated circuit, and our socket. So this little soldering iron I have, you can actually get from direct from China for about $5, or you can find them on Amazon for about 10. We're going to see how well that works. It actually plugs in with a standard USB plug. The other end that goes into the soldering iron is more like an audio jack. But yeah, it's not actually an audio jack. So we plug that in there, and then we plug the other end into our USB hub. And surprisingly, it doesn't take that long to actually heat up. You just have to get close to this, or touch this little metal ball here, and then the red light goes on, which indicates that it's heating up. We have a sponge here with it's wet, so we can use to wipe our soldering iron. And we just have standard solder. I think the first thing that we'll put in is the buttons. Now you can see on this kit that's already made that there are 4 buttons on there. There's left, right, and then basically an A, B button for duck and jump. We'll go ahead and put 6 buttons on them so you can use this controller for other projects as well. So those just snap right in there, and they have plenty of grip, so they're not going to fall out while you're trying to solder them in. And then we're just going to put them in the standard controller configuration with our direction pad and then the A-B buttons. So those just go in right like that. And then we're going to go ahead and see if we can get this thing to solder. Now before soldering, you basically just need to check that you can melt that on there. Yep, that's plenty hot. There. You don't really want to breathe in the fumes from this stuff. If you just blow the fumes away a little bit, that's fine. Surprising how well this cheap little soldering iron powered by a USB adapter actually works. Alright. Now I have all these buttons soldered in there. So yeah, check to make sure you got them on. I missed those and those two. A little bit more to go. That's got plenty of solder on it. And we just check our board, make sure we got everything soldered on there correctly on it. Looks like it. So now we've got 6 buttons soldered into the board. The next thing we're going to do is the 16-pin socket, and that goes right here. Notice there's a little notch there, and there's a notch on the thing. We just want those to line up. We're just going to slide that right in there. The reason we're using this instead of putting the integrated circuit directly into the board is just in case there's an issue with that, or if we accidentally fry it later, we can pop it out and we don't have to have a huge deal with fixing our board. When we're soldering stuff, sometimes we need a little help holding the pieces in place, so we can just take some standard Scotch tape, put that over that, that'll hold it up there nice and tight. And now we can go ahead and solder this in. Second the heat. There we go. Make sure we got plenty of solder on each of these joints. Alright, just set that down, check our work, make sure we got all the pins on there that are soldered. Those look good. Take the tape right off of that. Now we got our little socket on there. The next thing we're going to do is the capacitor. Actually, yeah, we'll go ahead and do the capacitor, that's fine. So you just stick that in there. It doesn't matter which way you put it in. These ceramic capacitors aren't polarized, so it doesn't matter. There's no explicit positive or negative on that. So you just put that in there and then bend the leads off to the side, and that'll hold it in there nice and tight. And then we can do the same thing with the resistor. Just slide those right in there. Hold it in there nice and tight, so it's nice and firm against the board. Bend it off to the side. And go ahead and solder those on there. Make sure we got enough. Yep. And I can just use some simple basic cutting tool you can get at Home Depot. What we're going to do is we're going to cut off the extra leads on here close to the board. Alright, I got our buttons, resistor, capacitor, socket all put in place. The last bit is we're going to put in the header pins. So we need, let's see here, we're actually going to need, if you look at our demo one here, we have 1 pin here, 3 here and 2 here. So these 2 pins are for power, these 3 pins are how we select which button we're reading, and then we just need 1 pin going to the out so we can see if the button was pressed or not. So that gives us a total of 6 pins that we need. So we're going to count off 6, 1, 2, 3, 4, 5, 6, and then just snap that right off. So now we need 3 that are going to go in there. It's a little easier if you only need one of them to use a needle nose pliers. Just snap that right off. Okay, so we're going to have 1 that's going to go here. 2 that are going to go over there for power. So you can see those in there. Just have 6 little header pins. This one is reading to see whether the button's pressed or not. These 3 are selecting which button we're looking at, and these 2 are for power and ground. And then there's an extra power and ground, so you can chain these boards to additional boards, run power from the Arduino to this board and then from this board to another board. But we're not going to need that for this project, so we'll just leave those unpopulated. So we're going to take this one out for a second while we focus on these 5, and we're just going to use tape again. Hold those in place while we're soldering them. Make it a little easier. They don't have to be on exactly straight. So we're just going to be using those to attach some wires. Alright. Yeah, there we go. Alright, so the way this works is that this lines up this way, so we have that little line up there, so this would go in like this, and then it's just rotate the leads, or the lines are just traces, are just rotated 90 degrees, and so all of these line up this way. So if you wanted to populate this whole thing with these nice little connectors, they would just all go in like that. And of course these are standard 2-pin connectors, which are just like this but with only 2 pins, but we're not going to use these for this project. We're going to go ahead and just use standard header pins. So again, we'll use tape to hold that in place while we solder it. So you just take a little bit of tape to give it some, just hold it in place nicely while we solder that right there on the board. For that. So we just have our first 4 pins. We're putting these up top just so they're close to the display later. Take the next 4, we'll just put these right in here. Put this tape there to help hold it in place while we solder it. Doesn't have to be really that straight, just do your best on this. Alright. So just make sure we got that soldered on there nicely, so we got all 4 of them soldered. It's going to be a little warm, that's fine. And now we take our 2 header and we're just going to plug it into this bottom one so it's close to the controller board. Let me put everything together. These little, you're only putting in a couple pins, it can be a little bit of a pain. Alright, so we're going to put that in there. That'll just help hold it in place. Go ahead and solder that. A little extra solder, that's fine. Let's use our sponge to, so you see we're just using our sponge to try to clean that off a little bit. Alright, and that's all there is to this one. So for this board we just have 4 header pins up top. We got 4 header pins to the side and 2 little header pins down at the bottom. So that's power, goes to the Arduino, goes to the display. And of course this already has the ground and power, so we don't need extra ground and power pins for that. And then we'll go ahead and set this off to the side. And then the last bit of soldering we're going to have to do is the Arduino itself. You can order these from China pre-soldered. It just costs you a little bit more to do that than getting it without the pins pre-soldered in there. So one thing that makes this board a little more challenging is that the labels are pretty close to the pins, and we want to have these header pins on top. You don't actually want to put them on the bottom, because you can see from this demo board that we're going to be wiring up things to the top. We're going to be gluing the Arduino to a popsicle stick on the bottom, so we can't have the pins on the bottom of that. So we're just going to go ahead and do that. Now these 6 pins here go into the bottom of the Arduino, and this is actually another way to program it. There's some programmers you can get that will write your program to this chip using a standard 6-pin connector, so we actually don't need to solder these in. So we're going to just set those off to the side. We're just going to solder in these header pins. So we're going to go ahead and put both of those in there, and then since it's level, we're just going to set it down on our workspace, and then let's go ahead and start soldering. Basically, once you get one pin soldered, that's going to hold the rest of them in place. They're not going to move around while you're soldering once you get one on there, and it has a second to cool off. These little nanos can be had for pretty cheap, and if you order them from AliExpress, you can get them for under $2 each. So they're very cheap, and I haven't had really any problems with them. So whenever I order something from AliExpress, I like to expend at least $20 on whatever it is or whatever part it is I'm ordering, and that usually gets me a lot. So with the Arduinos, $20 will get you about 8 to 10 boards, depending on how much shipping is. And if there are any issues, it's really not a big deal, because you've got plenty and you've saved a lot of money compared to what you would pay retail buying from Amazon or even on eBay. Alright, so once we got it soldered, we just wipe the soldering off on our sponge, and then we just want to check and make sure we got everything and that all the solder joints look good. So this looks fine, so we've got both sides on, they're on there straight. Again, we don't need these 6 here. We're going to be programming this Arduino through the USB connection. One of the things I'm including with these kits is this is a mini to micro USB adapter, and so you can plug this into here, and then you can use a standard connector, which is common with cell phones these days, which is the micro USB. So that's just a convenience thing. I'm also including the actual micro or the mini USB to USB adapter, so you can use this to plug directly into your computer to program it. Alright, and that's it. That's actually it for all the soldering that you need to do with this project. You're just putting the header pins on here, header pins on the I2C board, and the controller is the one, of course, that took the most soldering, but not terribly difficult. If you haven't soldered before, I include these little PCB boards in here, prototyping boards. What you can do is you can use graphing paper that has the same number of holes, basically, or dots, and create a design, and then just practice soldering wire to this little board. These are really cheap. If you're looking for cheap wire, obviously don't cut up a network cable you actually use. But I found that network cables are actually one of the cheaper sources of wire. So if you just go to a store and pick up a length of network cable, you can chop off the ends. And there's 4 twisted pairs in here. So that's actually 8 different wires. And so you can just cut this to a length, and then you'll have plenty of wire to practice soldering with. And you can get a network cable for like $5 or less. And then the last piece to talk about is the actual display. Now, there we go. The right tool when you can use the wrong tool to get this job done. Alright, so these boards come in a couple different ways. Some boards have this adapter already soldered to it, which is super convenient, so in this case we don't have to do any more soldering. I'm going to take this little plastic protector sheet off of here. There we go. Let's take that right off. So if some ways you can buy this is where these aren't already connected, in which case you would get this screen, which can be hooked up directly to an Arduino. You don't need this particular adapter board. This is a serial to or a parallel to I2C board, basically. So this takes all the connectors for this display and converts it into to be compatible with I2C, which is a lot nicer to hook up. So there's only 4 wires to hook this up to an Arduino instead of like 16 wires that you would have to hook up without it. So combined, this is about a $2 thing or less. So yeah, since we don't have to solder it, we just got to keep in mind this is 2 separate distinct pieces, so that you can't just buy the display, you also want to get the board with it, either attached already or you'll need to solder that in. So these are our main pieces. So we have the Arduino, we have the I2C hub, we have the display, and we have our controller. And then we have, it takes 14 wires for this particular kit to put it together. So these are included. You get 14 female to female wires, which will go from the Arduino to the various connections. And we'll go over those connections in a minute here. To assemble it together into one complete project, you just use 5 craft popsicle sticks. You could, of course, use some 3D printed case, or you could use foam board. There's any number of things you could use, and then I just use a cheap hot glue gun you can get from the craft store for $2 to $5 to glue it all together. I would highly recommend that you actually put this, wire this up first, test it, make sure everything's working before you glue it to the popsicle sticks, in case there's something that doesn't work, in case there's a, you know, if this is defective or whatever, or this is defective. It's a lot harder to deal with that if you've already glued everything together. So you'll want to program this first. Now, the other thing to keep in mind is that the Dinosaur game does not come pre-installed on the Arduino. You will have to download the document and type it in. That's the educational part, is that you'll actually be typing in the code, and that will force you to actually read through all the code, learn it, give you some experience typing, all that fun stuff. So all that information is contained in the documentation on the Retro LCD website. Available on the website as well is a pin out diagram for the Arduino Nano, and based on the way we attach this to the popsicle sticks, it's actually going to be orientated like this. You may, of course, you're going to notice that there's multiple names for a lot of these pins. These are just, some of these pins just have a lot of different uses. Like, these are analog pins. You can reference them by the different names and stuff. I mean, you'll want to look into the Arduino keyword and reference guides for exactly how these are referenced in different ways. But you see here that A5 is also the SCL line, and A4 is the SDA line. Those are the I2C connectors that we'll be using, that will be going into our hub. And then we have the ground pin. Actually, we have a ground pin right here and a 5-volt pin that will also, those make up the 4 wires that go into the I2C hub. And then everything goes out from there. Yeah, and that's actually basically it for the Dinosaur game. We're going to be taking up a few of the digital pins here to do the selector, and then one of them will be used as an input line to read whether the button has been pressed or not. So the other thing we have is the wiring document that just tells us how we're going to go from, how we're going to use each of these wires to wire this up. So this, along with this, will help you out, because as I mentioned before, once you put the header pins in the way we've set them up, it kind of hides the names of some of these pins, so you might need to count. So if we orientate this to match the diagram, it'll be easier to line up these wires and figure out which ones go where. So I think what we'll do first is let's wire up the controller actually. So we'll need 3 wires for the selector. So we're just going to put in 3 wires here. So we just got 3 wires right there. It doesn't matter what color they are. We just need to keep track of which one's which. So on this board we have it labeled A, B, and C. So we're going to look at our wiring diagram here, and this just matches the code that you can type in. So we're going to use digital pins 3, 4, and 5 is going to be A, B, and C. So 3, 4, 5. So it looks like brown is going to be our A pin. So we got A, B, and C, 3, 4, 5. So we can go to our Arduino, and we're going to find pins 3, 4, and 5. And actually those are right here. So upside down actually goes in the right order. So we got pin 3, brown, oops, red is 4. Sometimes these can pop off on their own, which is, that's alright, just gotta make sure they're on there nice. Okay, so now that's wired into 3, 4, and 5. And then we need 2 wires for power. I usually like to use black and red, but it doesn't really matter. So we're going to use red for power and brown for ground, which makes sense too. So the convention on these boards is that this side is power, left side is power, right side is ground. So there just going to wire this into here. We're just going to match that up since these are wired to match. So red goes on the left, brown goes on the right. Now that matches. Okay, now we got these nice big thick wires that you have to shove things around. Alright. Okay, now that we got the controller hooked up and the power hooked up, now we need to hook up the display. So we're actually going to look on we'll use the already made kit so we can figure out what pins are which. So we have these 4 pins up here, so I'm going to draw a quick little diagram for that. Okay, so that's what our little connector looks like on the PCB. And we got 4 connectors going to that, and those are going to be going to the display on the back. So here we've got our left pin is gray, and if we look on the back, gray goes to SCL. So our left pin is SCL. And then we have a purple wire, and that is going back here to SDA, so that's our data line. So our next pin is SDA. And then we have a blue wire. We'll see where that's going. Blue is going to 5 volts. And that leaves us with our rightmost pin being ground. Okay. So now we have our little diagram to tell us which wires are going where. So we're going to take 4 wires here. Let's see here. 1, 2, 3, 4. And we're just going to plug those straight into here. And then we look on the back of our thing, so we got blue goes to SCL, and then that's going to be ground. So actually they're right in order here, so we're just going to squeeze those right on there, push those on those nice and firm. So you can see here that these actually line up. So blue goes to blue, blue, green, yellow, orange, blue, green, yellow, orange on the display. And then those are just going to twist a little bit to get there. Let's see here. And then the last, almost last one. So now we've got to do our pins here on the hub. So we can get those on there. Line those up, squeeze them all on at once. So, okay. Okay, and then you just gotta remember that these are actually rotated 90 degrees this way, so that's gonna give us this purple wire. Is our ground, so we're gonna look for the ground pin on the Arduino, which is the second pin here. And then that gives us the gray wire, which is this one, is going to be our 5 volts. So that's going to go to our 5 volt pin on our Arduino. And again, you'll want to use this reference sheet to make sure you're hooking up the right wires where they belong. And then our white wire, that is the SDA pin. And on the Arduino, SDA is A4. So we're going to put SDA on L4. And then we're going to put the SCL pin on a 5. So you can see that those are twisted, those are flipped around compared to how it is on here, but these line up with that, so that's fine. We'll keep it that way. Then we have one more wire, which is our output pin from our controller, which needs to be hooked up to an input pin on the Arduino. And according to this, so we're going to go ahead and put that into D7. So we just look for D7 on here, which is conveniently located. We're just skipping one pin from our selectors, and it's going to go right there. And that's all there is to it. So we've got our 14 wires, we have everything soldered, everything is hooked up, and we're ready to program this with the Dinosaur game to make sure that it works. Alright, so the last thing we need to do is we're going to plug this into the computer. And I've already typed in the code, of course, for this. And we're going to upload it to the Arduino. It's going to take a second for that to load. That's uploaded. And now when it first starts up, depending on how this board has been adjusted, there's actually a contrast control on the back. It's this blue little thing here. It just takes a standard Phillips head screwdriver, and you can adjust the contrast on that so you can actually see the game going, so you can see how it too bright and get those little squares. So you kind of want the squares to just kind of fade to the back and then just leave your characters displaying. And now we can see the dinosaur moving. You don't use the up and down buttons in this version, but that's what they're just there, so we can use this controller for other projects. So we have the dodge button and the jump button, and so we can see here that this kit is fully working, so we can jump over a cactus. When he gets hit, then he loses a point. So this game goes on forever. There's no end to this game. It's just a random cactuses coming at you, and you just gotta try to get out of the way and get as many points as you can. It's just a fun little game to test this out, demonstrate how to use sprites, demonstrate how to use a basic controller, your I2C, things like that. So this covers a lot of your basic game logic that you're going to be using in a lot of products going forward. So you can of course add all kinds of different things to this, modify this game to have different rules, different sprites, all kinds of fun stuff. But that's it as far as soldering it together, programming it, making sure everything works. And then the final step, now that we know everything is good, is we're going to assemble this and hot glue it to the popsicle sticks to make our nice little game system that we can carry around and not have to worry about wires popping off and all that fun stuff. We're going to go ahead and unplug all this. Alright, so let's start gluing this together. This is just a cheap glue gun from probably Michael or something. It costs only a couple dollars. I like to use a paper towel to set it on so all the glue that comes off of it's not wrecking your surface or whatever, your workspace, whatever you're working on. So the first thing I'm going to do is I'm going to stick this popsicle stick underneath the between the display and the controller. And it actually fits right in there. It's pretty much exactly the right size. They go in these little, in between these little clips there behind here. So we do need to leave some space because we're gonna also put these back here. So we're kind of wedging these ones together. There we go. That's just gonna kind of go like that. I want to try to keep it as straight as possible. We're just kind of eyeballing it. So the first glue we're going to do is we're just going to glue this popsicle stick, a craft stick, whatever you want to call it. We're going to glue that right in there. Looks like I'm already out of glue. Always have extra glue sticks ready to go. So we're just going to glue that on there, glue this on here. So you can't really use too much glue on this thing. I just use the paper towel to kind of clean that off. Okay, and then we're going to squeeze these in here. Try to get them straight. And then we're just going to hot glue this stuff in there. Just connect those together. Hot glue those together. There we go, just like that. That's fine. So we're in there. There we go. So that's all there is to that. We'll give that a second to cool off. Make sure that's all straight on there. Alright, and then the next one we can do is the middle one. This is the one that the Arduino is going to be stuck to. So let's go ahead and put some glue on there. A little glue on there. We're getting strings of it. I'm just going to squeeze that right on there. There we go. Careful not to get that on you, it's a little warm. Comes right off after a second though. Yep, so that's on there. So now we can turn this over and we are going to glue. This board is going to go right on here. Can I get this stuff over here? Kind of where it's going to go. So I actually want to put this up a little bit because we need space for the controller underneath here. So let's go ahead and get some glue on here. Shove a bunch on there. It's okay if it starts getting stringy, you can. So this is where when you're building your project, you're probably going to want to populate these because once you glue this on here, it's going to be a real pain in the butt to add any additional header pins on that board. Let's get some of this stringy stuff on here. Alright, then we're going to glue the Arduino on, so let's shove some glue on here. You want quite a bit on there just because there's components underneath here, and we want to make sure there's plenty of glue that's going to connect it to the popsicle stick. So just shove that right on there. And then we have the cross piece for the controller. So we're going to go ahead and squeeze a little bit of glue over here. Squeeze a little glue over here. Take this, put it right here. There we go. Give that a second to dry. Of course, you don't have to be very exacting with this. Just kind of get a generally in the right location. Alright, that's a little bit of time to dry. Let's go ahead and squeeze a bunch on here. And this is going to be where our controller goes. We're going to press that on there. And you have to hold it for a second to give it a chance to dry enough so it doesn't pop off. And check underneath to make sure everything looks good. There we go. And really the idea of using popsicle sticks is just to show that there's a quick and easy way to put together a little project without spending a whole lot of time learning how to do 3D printing, which of course would be fun to do and you can certainly do on your own time. Eventually may put up tutorials on that as well, but for now our main focus with Retro LCD is to teach game programming. And so we're going to be creating standardized components and then switching out some certain things like different type of controller. May have mentioned this earlier, but these chips, these nice little dip packages with the multiplexer seem to have been discontinued by Texas Instruments, so not sure how much longer those are going to be available. You can get the surface mount, which of course is much more difficult to put on there. But I have another controller idea that we'll be putting into practice, so it won't matter. The other thing we're going to be switching out in a future project is we're going to be using different types of displays, and and of course different types of games that we're going to be making with this. So like I said, the main focus is on game programming. This is the first in many projects that we can do with this to demonstrate how different styles of games work. So this is an example of a simple walk around jump duck type game. It's not even a platformer really. And then in the future we'll have Tetris. We have electronic basketball. We'll do a fighting game. We can do all kinds of different things. So we're going to have a lot of fun with this. This is just the first project, just to get you started, just to get you acquainted with the idea that the Arduino actually makes a good system to learn game programming with. So let's go ahead and plug this in so we can make sure everything still works. We'll go ahead and use this adapter here. This thing conveniently fits on here, even with the popsicle stick here. So we'll just plug in. So I found these cheap little plug-in micro USB ones, so we'll go right in there. So we can just plug that in. We see the blocks come up top, and then we're running. So now we've got a fully working Dinosaur project. The next thing to do, of course, is to think about what kind of games you could make with this. What kind of game you could make with just having 2 lines of text to work with and different sprites. So check out retrolcd.com. We'll have the printable documentation for how this game works, the source code, how the sprites are created, how this controller works, so you can use it for multiple projects if you want, as well as a lot of other just information that's going to be continually to be built on, so you can learn how to do more and more advanced game programming projects, and eventually maybe move into the actual PC and do some pretty cool stuff with that, having a good foundation of how games actually work.